Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 2.1, the addition property of equality. In this video, we will identify linear equations in one variable, and we will use the addition property of equality to solve equations. Let's get started with some definitions. Definition. A linear equation in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers and a is not equal to 0. That's a linear equation in one variable. Okay, we need one more definition to get started here. On this page at least. So the same real number or algebraic expression may be added to both sides of an equation without changing the equation's solution. So symbolically, if we have that a and b are equal, if a equals b, then if we add c to both sides, nothing changes. A plus c will still be equal to b plus c. What this says is that we can add or subtract any number or algebraic expression to both sides of an equation, and the equation will have the same solutions. This property, that you can add the same number to both sides without changing the equation solution, is called the addition property of equality. We need one more definition before we do an example, and that definition is that the set of an equation's solutions is called its solution set. So all of the solutions for an equation are in a set, which we denote with curly braces, if you'll remember that. And all the solutions go in there. That's the solution set. Let's get started with an example. Example 1. We want to solve the equation and check the solution. And our equation is x minus 5 equals 12. Okay, so notice that on the left-hand side, we have 5 less than our number x. And what we want to solve for is x. Well, if we have x minus 5, the way we undo subtraction is with addition. And so to get rid of the 5 on the left-hand side, we need to add 5 to the left-hand side. Well, the addition property of equality says that if I add something to one side, if I want the equation to have the same solution, I need to then add it to the other side. So x minus 5 plus 5 is just x, and 12 plus 5 is 17. So our solution is x equals 17. Now we need to check that solution. If we plug in 17 for x and subtract 5, we get 12, which is exactly what we started with. So x equals 17 works as a solution. And that's how you use the addition property of equality to solve an equation. Let's try another example. Example 2. Solve and check. This time our equation is z plus 2.8 equals 5.09. So we want to solve for z. We have z plus a number, 2.8, is equal to 5.09. So to isolate z and get it by itself, we need to subtract 2.8. Well, if we do it to one side, we have to do it to the other, so we subtract 2.8 from both sides. Z plus 2.8 minus 2.8 on the left-hand side gives us just z. And 5.09 minus 2.8 gives us 2.29. Okay, so our solution to this equation is z equals 2.29. That we can plug in 2.29 for z. 2.29 plus 2.8 gives us a result of 5.09. So z equals 2.29 is the solution to the equation. Example 3. Again, solve and check. This time we have an equation that has fractions in it. Negative 1/2 is equal to x minus 3/4. Okay. So if we want to get x by itself, we need to add 3/4 to both sides. And negative 1/2 plus 3/4. Well, negative 1/2 is the same as negative 2/4 plus 3/4 is equal to x minus 3/4 plus 3/4 is just x. Negative 2/4 plus 3/4, negative 2 plus 3 is 1. So 1/4 is equal to x. So x equals 1/4 is our solution. We can check that by taking 1/4 and subtracting 3/4 as we see on the right hand side. And 1/4 minus 3/4 is negative 2/4, which is the same as negative 1/2, which is what we got, what we started with. So x equals 1/4 is the solution to the equation. Again, the boxed answer is our solution. Let's try one that's a little bit more complicated. Example number 4. Still, we want to solve and check. And we have 8y plus 7 minus 7y minus 10 equals 6 plus 4. Now, the first thing you may say is, well, can I just add the 6 and the 4 on the right-hand side? And the answer is yes. So we'll just copy everything from the left-hand side and leave it the same. And 6 plus 4 equals 10. Now on the left-hand side, we can combine like terms. We have an 8y and a negative 7y. 8 minus 7 is just 1, so we have y plus 7 minus 10 equals 10. 7 minus 10 is a minus 3, so y minus 3 equals 10. Now we're only one step away, and we can add 3 to both sides to get y by itself, and y is equal to 10 plus 3, which is 13. Okay, so going back and checking this, we can say that 8 times 13 plus 7 minus 7 times 13 minus 10. We want to check that to see for sure that it equals 6 plus 4, which is 10. So we start with the first multiplication, which is 8 times 13. 8 times 13 is 104 plus 7 minus 7 times 13. And I can do that math. 7 times 13 is minus 91 minus 10. So 104 plus 7 gives us 111 minus 91 minus 10. 111 minus 91 gives us 20 minus 10, and 20 minus 10 is 10. So y equals 13 is the solution to the equation. Example number 5. We want to solve and check. Okay, we have 7x is equal to 12 plus 6x. Okay, so now we have the variable x on both sides of our equation. That means now we have to add or subtract with a term that includes the variable. So which one do we want to subtract? We want to subtract the one that will give us a positive value of x on one side. And so what we want to do is we want to subtract 6x from both sides. 7x minus 6x is 1x on the left. 12 plus 6x minus 6x gives us just 12. And so we've now isolated the variable which is x equals 12, being our solution. So we can check that to make sure. And 7 times 12 is 84. 12 plus 6 times 12 is 12 plus 72 equals 84. So 84 is equal to 84. Therefore, x equals 12 is the solution to the equation. Since we were able to get a true statement from our checking step. Let's do one last example. Example 6. Solve and check. Okay, this time our equation is 3x minus 6 equal to 2x plus 5. Now again, just like in the last example, we have the variable on both sides of the equation, and this time we actually have constants or numbers on both sides of the equation. So the first thing I want to do is I want to move the numbers to one side, and then we'll move the variables to the other. So the first thing I'll do is add 6 to both sides. So on the left-hand side, I end up with just 3x, so minus 6 plus 6 will cancel. And then on the right-hand side, I have 2x plus 5 plus 6. 5 plus 6 is 11. Now I have 3x on one side and 2x on the other. If I subtract 2x from both sides, I'll get 3x minus 2x, which is just x. The 2x's on the right-hand side will cancel, and I'm left with 11 as my solution. Okay, we want to check to see if this is the correct solution. So we do 3 times 11 minus 6. And we're going to check to see if that's equal. We don't know for sure. 2 times 11 plus 5. Okay, 3 times 11 is 33 minus 6. Again, we don't know for sure. 2 times 11 is 22 plus 5. 33 minus 6 is 27, and 22 plus 5 is 27. So we know those two things are equal, so we can drop our little question marks. And since we get a true statement, x equals 11 is the solution to the equation. Okay, that is the last example of section 2.1, the addition property of equality. If you have any questions, let me know. Good luck on your homework, and I'll see you in the next one.